Hello and welcome to Mr. Davis's classroom. This is Algebra 1, and today we're on lesson 7.2, which is scientific notation. 7.2 is broken up into two parts, so today we're going to do the first part. We're going to talk about writing numbers in scientific and then standard notation, or going back and forth between the two. So scientific notation is something that you've probably seen before. We just want to make sure that you understand that scientific notation needs to be written as some A value. That number in the front, what we call an A value. So see how there's an A there, and the three numbers in front. Those are called our A values. The A value has to be 1 or larger, but not bigger than 10. We always have times 10 on every scientific notation. So always times 10. And then the exponents tell us where the decimal goes. So whether it's a large number or a small number. And so that's what standard notation looks like. Now let's try 3, where we want to tell if they are or are not scientific notation. So let's look at number A. If we look at A, we have 0.23 times 10 to the negative third. Well, things that I see that are perfectly fine, right? Base of 10. Exponent is good, right? It's a whole number. It's good. But there's something wrong with that A value. Right? That A value is less than 1. Remember, we want our A values to always be between 1 and 10. Right? Only one digit on the outside of the decimal place. So this is no. It is not in scientific notation. The reason why is because of the A value. It is not bigger than or equal to 1, but less than 10. Okay. Let's look at part B. Part B, let's see. Well, the A value looks good this time. Well, that's good. It's still times 10, so it's got that same base. And the exponent looks good. Yes, it's scientific notation. Everything checks out on it. Last one. Well, A value still good. Exponent looks good, but what about my base? Right. The base here is 100, where in scientific notation the base needs to be 10. All right, 10, not 100. Always 10, never anything else in scientific notation. Here's 3 for you to try. If you need help, refer to the previous problem, your notes, or the book. All right. Problem 2 is to write a number in scientific notation. I'm going to use this time to explain the exponent's job in scientific notation. So there's 2 parts to the exponent when we have scientific notation. I'll just use, so we have some A value times 10 to the some power, right? There's going to be some number up there. So right now I'm only talking about that number right there. Well, whatever number that is tells you how many places to move the decimal. Okay? So that tells you how many places to move the decimal. So if I just refer back to these examples, on A, even though it is not correctly written in scientific notation, but if it was, 4 would tell us that we need to move the decimal 4 places, 7 places, and that would be a 1 if it was the correct base. So let's see, that tells us how many places to move. And the other thing is, it can be a positive or a negative sign, right? We've seen both those. The positive tells us to make a large number. Okay? So any positive exponent is going to tell us to make a large number. A minus sign is going to tell us to make a small number. Okay? And if you remember from lesson 7.2, a negative sign tells us to make a fraction. Right? So these fractions that we're making are going to be a small number on top of a very large number on bottom, which makes it close to 0. So those are the things we need to pay attention to. All right, so we have approximate distance between the Sun and Saturn. Ooh, between the Sun and Saturn. That is a large number. Large number tells me I'm going to be using a positive exponent. All right? So what we're going to do here is, here, I'll go ahead and write, we have a times 10 to some power. Let's first off put down the a value. Remember, the a value always has to be a digit point something. So here we have those 3 digits before it's all 0. So I need to write all those digits down. So I'm going to have 1.43. My a value is correct because I didn't write 0.14. I didn't write 14.3. I wrote 1.43 times 10 to the what power? Well, my decimal place starts off, and I'm going to get myself a little bit of room to write. The decimal place starts off right at the end there, right? We have now moved it. When we moved it here to the a value, we moved it to right there. What I want to count is how many places to move the decimal. Right? So I went 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is a large number, so we know we're using a positive number. All right, let's try B. B is a little bit different because of instead of a large number, it's a very small number. So we need to make a small number with a negative. Again, I need to make my a value. Now, if I want to write it without all those zeros, I need to wait until I get to 1, right? Now, I could write it, some people will write it like that, 1.0. I don't feel like it's totally necessary, so we'll just write it as 1. Okay. But now we need to count how many places to move the decimal. Let me move back up. How many places to move the decimal, right? That's this one right here. Well, we started off here. Our a value, we moved the decimal there, so we need to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 spaces. And we're making we're dealing with small numbers, so it needs to be negative 10. All right, and that's it. All right, try these ones right here. If you need help, refer to the previous problem. All right, so here we have 2 that are in scientific notation. They want us to write them in standard notation. Yeah. So let's start with A. It says the weight of an Asian elephant is 5.5 times 10 to the 6th grams. Well, a couple things already that I see. One, we have a positive exponent. That tells me it's going to be a large number. And I'm confirmed in my beliefs because we're talking about an Asian elephant. An Asian elephant is a large animal. So what I want to do is I want to take the information they give us here and translate it. So again, positive number, we have positive exponent, tells me it's going to be a large number. The 6 tells me how many places I'm going to move my decimal. So I'm going to make a little bit of work. So I have 5.5. The 6 tells me I'm going to move it 6 places to make it a large number. Right? So I need to move it to the right to make it larger. I'm going to go 1, 2, 3, 4, 5, 6. My decimal place is now here. What am I going to fill in all those spots right there? The answer is zeros. They are all zeros. So I get 5, 5, 0, 0, 0, 0. See, that's 4 zeros. I need 1, 2, 3, 4. I need 5. So 5.5 5 million grams is how much an elephant weighs. All right, if we talk about the weight of an ant, okay, negative exponent tells me it's a small number, which makes sense because we're talking about an ant. It's very small. So we have 3.1. The negative exponent tells me I'm going to move it to make this a small number. Right? If I want to make it a small number, move 3 spaces to the left. 1, 2, 3. And again, we fill in the empty spaces with zeros. 0.0031 grams. All right, very good. Let's try a few on our own. If you need help for the previous problem or your notes. And here's your homework assignment. All right. Thank you for coming to Mr. Davis' classroom. I hope you enjoy.